Now, let us have an example of adding vectors using their components. Suppose these are the given vectors. We have vector A, whose magnitude is 5 Newton, and it is 125 degrees counterclockwise from positive x-axis. We have vector B, 8 Newton, magnitude is 8 Newton, and 35 degrees from positive x-axis in counterclockwise direction. And vector C, which is 3 Newton, and 110 degrees from positive x-axis. And we wish to find vector A plus vector B minus vector C, which is equal to vector R, and we will look for vector R using their components. Okay, so first thing to do is to find the x and y components of vector R. Okay, let us find first the x component of vector R, which is R of x. So we have here R of x is A of x. So that's the first vector, vector A. So we have A of x plus, since that's plus vector B, so this is B of x. Since this is minus vector C, then we have minus C of x. All right. So what is this A of x? So that is the magnitude of A, which is 5 Newton. Cosine of its direction from positive x-axis counterclockwise direction, which is 125 degrees. So that's cosine 125 degrees plus, what is this B of x? That is the magnitude of vector B, which is 8 Newton. Cosine of its angle, its direction from positive x-axis in counterclockwise direction, which is 35 degrees. Minus C of x, which is C of x is 3 Newton, magnitude of vector C, 3 Newton, cosine of 110 degrees. Okay? So that's approximately equal to 4.71 Newton. So you can double check it using calculator. Okay, so we have now the x component of vector R. Next is to look for the y component of vector R. So we have R of y equals A of y plus, since this is plus vector B, then we have plus by minus, since this is minus vector C, so we deal with subtraction of vector, so minus vector C, no, that's minus C of x, C of y, I mean that's the y component of vector R. So what is this A of y? That is the magnitude of vector A, which is 5 Newton, sine of its direction from positive x-axis, which is 125 degrees, plus by, which is 8 Newton, sine of its direction, 35 degrees, and then minus, which since it's minus vector C, so minus 3 Newton sine of 110 degrees. So we have R of y equals 5.87 Newton. So we now have R of y 5.87 Newton. So this is the y component of vector R. So next is to determine the magnitude of vector R. We have magnitude of vector R, which is R, no arrow above this letter R, equals the square root of the x component, R of x squared, plus the square of the y component. So that is the square root of, what's R of x? 4.71 Newton squared, plus R of y is 5.87 Newton squared. So we have, that's approximately equal to 7.52 Newton. So you can check if it's correct. You can use your calculator. So we have now the magnitude of vector r, which is 7.52. So let's go back to the x and y components of vector r. X component is positive, the y component is positive, so x and y are all positive. Then it means if we're going to use graphical method of determining the sum of vectors, then we can find the resultant vector at the first quadrant. Okay, since x and y components are all positive. Now, how about the direction of vector r, which is theta? And that is the inverse tangent of r of y over r of x, or theta as the direction of vector r from positive x-axis in counterclockwise direction. We have inverse tangent of what is r of y, 5.87 Newton over r of x, which is 4.71 Newton. Then theta as the direction equals approximately equal to 51.25 degrees. Okay, so this is the direction of vector r from positive x-axis, counterclockwise direction. All right, or so we have vector r equals the magnitude, which is 7.52 Newton, comma, the direction 51.25 degrees. So this is how it looks like when we are going to use the graphical method of determining the sum of vectors. So the given vectors are vector A, whose magnitude is 5 Newton and 125 degrees from positive x-axis. So here, this is vector A, okay, and it is 125 degrees from positive x-axis. This is the positive x-axis. And then the next given is vector B, whose magnitude is 8 meters and it's 35 degrees from positive x-axis. So if this is the axis that is parallel to this one, the positive x-axis, so that is 35 degrees counterclockwise direction from positive x-axis, and this is vector B. Okay, and vector C, whose magnitude is 3 Newton, we wish to look for vector A plus vector B minus vector C. So since this is vector's negative vector, then it goes to the opposite direction. Instead of going at that direction for vector C, it goes to the opposite direction since this is a negative vector. So this is negative vector C. Okay. So since that's 110 degrees, 110 in counterclockwise direction, then it will be 70 degrees in counterclockwise direction. So this red broken line represents vector r as the resultant vector of vector A plus vector B minus vector C. Okay, do not forget the process of determining the sum of vectors by graphical method. You need to lay the vectors one after another by placing the tail of the succeeding vector to the head of proceeding vector, And then the vector drawn from the tail of first vector to the head of last vector indicates the resultant. It represents resultant vector.